Alright, let's sketch the following function. F double prime of x is less than 0 when x is greater than negative 2 and less than 1. F double prime of x is greater than 0 when x is less than negative 2 and x is greater than 1. And f of negative 2 is negative 4 and f of 0 is equal to 0. So what I want to do here is first, I'm just going to plot some of these points that are given. So f of 0 is 0. So it's the point here is 0 and 0. The other point here is negative 2 and negative 4. So let's just put that here. Okay, and we can understand that f double prime of x less than 0 means that the graph should be concave down between x's greater than negative 2 but less than 1, right? So if the graph is concave down between negative 2 and 1, right, we should see that it could either be sloping this way or that way, right? And we also know that f double prime of x is greater than 0, right? It's concave up when x is less than negative 2 and when x is greater than 1. So because in between these points, specifically 2 and 1, we should expect a point of inflection because we should see there should be a shift in concavity from concave up to concave down, right? So we should have a point of inflection in negative 2, so specifically negative 2 and negative 4, as well as at 1, right? So in this case, we know that when x is less than negative 2, it's concave up. So let's say that a potential graph looks like this, right? And your answers can vary here, right? So let's say it's concave up until this point, concave up. And then we know that at negative 2, it should be concave down, right? So it should be concave down, and it should pass through 0 and 0. So this is concave down, right? And you could do it this way. I think the more natural essence of this would probably look like that. Okay, so this portion here would be concave up. Okay, so this would be concave up. So this is concave down. Right, so it's concave down between negative 2 and 1. And then maybe at some point 1, it becomes, when x is greater than 1, becomes concave down, concave up, sorry. So maybe it does that. Okay, so we're just, once again, this is just a sketch, right? There's no right or wrong answer for this, right? As long as you follow suit, right? So between negative 2 and 1, you should see a concave up portion, a concave down portion, and between x is less than negative 2 and when x is greater than 1, we should see a concave up portion. Okay, so just according to the first derivative test, second derivative test, and we also should see that when f double prime of x is equal to 0, this is basically a point of inflection, and this should occur, f double prime of negative 2 should equal 0, and f double prime of 1 should equal 0. So we should have 2 points of inflection. Okay, so this is what our sketch can potentially look like.